Well, good evening or good afternoon whenever you're watching this. We're going to continue our look at set theory, and this time Venn diagrams and set operations. Wow, what a list. Actually, it's not too bad. Come on. Each one again, simple, maybe a few interesting ones, but not too bad really. Universal set. First of all, let's get my pen going here so I can make comments. And let's get back. There we go. Universal set is all the elements that you are interested in. Let me get my pen here so it looks a little bit better. There we go. All elements under discussion, the ones you're interested in. Invented by John Venn. If I remember right, he was a high school teacher, high school math teacher probably, but he wanted to show the visual relationship among sets, which makes sets a little bit easier to understand. It's represented by a rectangle, and all the sets inside it or made up from that set are put inside, usually in circles, but you can make any shape you want to. Here's a Venn diagram. You can see here's the universal set. I think I might be inclined to put that outside so you don't think U is part of the answer. Inside, okay, this looks pretty good. The A indicates that everything inside that blue circle belongs to set A. Inside set A, what do we have? We have a square and a rectangle from the looks of it. What do we have outside set A? A dollar sign, capital M, and a 5. Interesting. What is U? U is everything lumped in together. So if you take all those things, dump them into one big cup or bucket, that's your universal set. In fact, the way I remember it is, here's U for the universal set. If I take all those buckets that have pieces of sets, just dump them inside. What does it make up? The universal set. Oops. Sorry about that. Let's see. Thought I had an erase feature here. I guess not. Oh, there we go. Okay. So there's your universal set, everything that's inside the rectangle, every element that's inside. Take a second and take a look at it. Wait, what? That's sort of weird. Triangle, blah, 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 5M. Where's the W? Am I missing something? Should be 5 things there. There's 5, the M, dollar sign, triangle. Okay, I think they made a little bit of a mistake here. This universal set, where are we again here? This universal set, this should be a square. So we'll have to take 1 point away from the slide maker, right? All right, now we're back to normal. Had me wondering though. I hope you were too. So, B. What's this look like? Well, A is represented by a circle. Inside A is what? As we should in this case. We've got 2 things inside set A, and we've got 3 things that are not inside set A. So set of elements in U that are not in A? Did you pause and write it down? Hope you did. And it looks like that one is correct. At least they didn't have the W in there because W supposedly was in A. Anyway, moving along. Disjoint sets, they don't have anything in common. Proper subsets, one is inside the other. Remember proper subsets? We talked about those a little bit earlier. Like A is a proper subset of B. If everything in A you can find in there somewhere, and B has some extra items, which makes it a proper superset, really. But A is a subset, proper subset of B. Of course, not proper subsets because there wouldn't be any extras because they are the same elements. If they have some common elements, over here, some common elements, those common elements are represented by this intersection. Anything inside here, if you look at the picture, it's in A, but it's also in B. And those are the common elements, or the intersection. Use the Venn diagram to figure out what U is. So U, what's that? It's the universal set. Where's my, okay. So U, can you fill in the blank? It should have everything inside the rectangle. So you have what's in A, what's in B, what's outside the meter. They'll tell you what it's supposed to be. Oops. Okay, I'm mistaken. Well, they didn't explain it too well. So let's go back a second here and see if we can clear things up. This is the name of set A. This right here represents the region around the A, B, and C. 2 represents the name of the region that has D in it. And this is the Roman numeral III is the part of B that contains the E. My apologies. And this IV 4 means region 4. Now region 4 contains F and G. Sorry for the confusion, but that's something you might have run into, so you can see how we don't want things that are in B. So scratch this out, and what we have left is the elements in A that are not in B. A, B, and C. Roster method. Set of elements in U that are not in B. So what you can do is you can start with U. In fact, if you want to do this, let's call this set R maybe. And R is a set of elements that are in U but not in B. So one way you can do this is start with a rough draft, so to speak. It says in U but not B. So why not start with everything that's in U? So you've got A, B, C, D, E, don't forget F and G. And then it says, we're not quite finished, not in B. Well, we don't want D and E then. So we'll scratch out the D, scratch out the E, rewrite it, and we've got our answer. Next, the set of elements in both A and B. So what we've got here, let's call this set S equals the set of elements in both A and B. So look at all those elements. You could make a master list if you wanted to, or you could start with, they have to be in both, so start with what's in A. So if you want to make set S, your rough draft, just your rough draft, start with what's in A. You got A, B, C, and D, and that's what's in A. But what you want are the ones that are in A and B. Which ones of these are also in B? Well, only D is, so you'll get rid of the ones that aren't also in B. And there's your answer. Next, complement. We actually talked about this. Complement means what's in the universe but not in A. Now, some places this might be referred to differently. You might see it referred to like this, not A, which would mean the universe, but not A. Okay, I guess we don't need that part. So what you can do is start with the universe, write all those parts that are in the universe, and scratch out the parts that are in A and see what's left. That's all there is to it. So here's an example we can use. Here we've got U. We want A prime, or the complement of A. So start with these and get rid of everything that's in A. So get rid of the 1, get rid of the 3, get rid of the 4, get rid of the 7, and what do we have left? We have A prime, or complement of A. In fact, another notation you might use, or could see, would be complement of A, sort of like this. Anyway, what's left? Complement of A, everything that's not in A, out of the universe, and there you go. And if you look up above, we've taken out the ones from the universe that were in A, and there we've got the complement of A. Next, intersection. That means the ones that are in both of those, both. So this is the word you want to remember for intersection. Intersection means you're talking about elements that are in both sets. Now, I'll give you a tip. I sort of look at it like this. We've got a set A here, and we've got a set B, and what I think of is since we use this intersection symbol right here, I think of it as seeing what I can cover that have both A and B in it, sort of like this. Maybe a better way is, that's my way of doing it, but if you see where they intersect, that's the part right here. So here's one to check on. Let's call this set A. Which numbers are in both lists? Write it down. 8 and 10. See anything else in both? Nope. 7 is not in both. 12 is not in both. Only 8 and 10. Here's another one to try. What's the intersection of these? You ready? It's two really good answers. I'm hoping you do. The empty set, which of course, if you remember, could be written like this just as easily. And also, oops, a reminder to you. This is not the empty set. This is the empty set. This is the empty set. This is definitely not, because it has something inside the set. And one more, the intersection of the set that contains 1, 3, 5, 7, 9, and the empty set. What numbers or members are in both of those sets? All right, what do you have? Remember, this first part has 5 different items. 1, 3, 5, 7, 9. What does this one have? It doesn't have anything. So what's going to be in both? Nothing. Now, we just talked about intersection where elements are in both sets. Now, here's where I really have a visual that I use. Since this union is represented, fortunately, with a U for union, I think of it as dumping set A in, dumping set B in. What do I end up with? Another way of looking at it is, what are the elements in A or in B? Remember, it's or. Intersection is connected with the word and. Union is connected with the word or. Intersection and. Union or. Like that. All right, here's one for you to try. We've got 2 sets. What's the union of those 2 sets? So remember, you sort of dump them all together. What set do you get? Usually a bigger set. Not guaranteed, though. Did you get the proper set? Did you get all 7? Notice that there were 5 elements in here. Remember, that's the cardinality of that set. Over here, there are 4 elements. So you might think if they didn't have any duplications, you'd end up with 9 members or 9 elements. However, there are some duplications. And you don't rewrite numbers because that's sort of silly. Another try. What's the union of those 2 sets? Pause, write your answer, and come back. And there's your answer. All of them this time, because they don't have anything in common. Or you could say nothing in their intersection. Okay, here's that empty set again coming back to challenge you. What's the union of the set that has 1, 3, 5, 7, 9 with the empty set. You ready? Because you want everything that's in either set. And of course it's the first set, because the empty set doesn't add anything to that original set. Next, these are two things you might keep in mind. If you take any set A at all, if you intersect it, remember that's an AND with the empty set, you get the empty set. Where am I here? What happened? Somehow my pencils decided to go away. Let's double check here, pen. All right. Still not writing. Okay, do it another way. Pen, good. All right, so and for intersection, any set intersected with the empty set, you get an empty set. It is being contrary, isn't it? Pen? It's really confused. Okay, let's go to the verbal thing then. Until it decides it's going to add. Number 2 says, take any set. The union of that with the empty set is the original set, because the empty set has nothing to add to set A. Next one, some problems have more than one set operation. And as you should be familiar with, always begin by working inside the parentheses first. Inside first. Let's see if the pen's back again. I don't see it, so we'll do without it. Next, set operations. So take a look at this. We've got two set operations. Remember, this is complement and this is union. The one on the inside is the union. So the first thing you do is take A union B. A union B gives you what? That'll give you 1, 3, 7, 8, 9, and 10. Now that's part way. That's what the inside operation does. But then we've got to take the complement of that. Remember, that's with respect to the universal set. That means here's the set of elements we've got right now. We want the opposite of those. We want what's in the universe, but not in this set. What's left? 1, 3, 7, 8, 9, 10. Okay, that's the union. So that's the first part. Part number 1. And you take the complement. What's left out of the universal set is 2, 4, 5, and 6. Another one to check out. Now, the first thing you have to do is figure out what are the inside operations. Well, if you look at this intersection, you think, okay, what do I take the intersection of? Well, I don't have them yet. I have to figure out what A complement is and what B complement is before I can take the intersection of the two. So there's A complement with the universal set, remember. There's B complement. And now we're going to take the intersection of those two sets. What do they have in common? A complement and B complement. And there's our result. Next, we're trying to make it a little bit more interesting. All right, so we've got a universal set. It has some things here. Remember, these are just region names. Tricked me there for a second. We don't need to be tricked though, do we? So A has pi, e, square root of 2, and square root of -1. B has square root of 2, square root of -1, e to the I pi, 10 to the 100 power, wow. And 2 to the, remember this, aleph null, the Hebrew letter. Now, what you want to do is determine each of the following sets. So for this first one, take a look, maybe make a list for yourself. What's in A? What's in B? You want the union, which means what's in A or B. In other words, like I said before, for union, you sort of dump the two sets together into one big set. What do you have? For the second one, we're taking part A and working it a little bit further for part B. So we take what we got in the previous one and take the complement of it. What is there in the universe that's not in A union B? Part C says, okay, A intersection B, that's simple. Where do they intersect? What points or what numbers do they have in common? So it's A and B for this particular set. Sorry, the words aren't coming out too good with a mouse. There we go. Intersection means and when we're putting the set together. Next, we've done that intersection part. Now we want to take the complement of the intersection. So you take everything in the universe and throw out what's in A intersection B. For part E, we're doing something a little bit different. Remember, first of all, you want to get the intersection of 2, so you're talking about an AND operation. Before you can do that, though, you know what's in B. You can see that from the picture in this B circle. But before we can do the AND operation, we have to figure out what's not in A. So figure out what's not in A, intersect it with what's also in B, and see if you can get that. And finally, F does things a little bit differently. You first have to find out what's not in B but in the universe, and you're going to dump it together with what's in A to get a final set. So here are the answers. If you didn't try them, jump back here, try them, go back here, check them out. If they don't check out, go back here, try it again. This is a good exercise to see if you really know sets and set operations. These are good ways of describing sets and ways we put them together. As I mentioned before, OR refers to union, and refers to the intersection of sets. Here's the formula for the cardinal number. Remember the cardinal number? That's how many elements you have in the set. If we want the cardinal for the union, cardinal number for the union, this is a formula for you. So we'll put a big star here. if you want the cardinal number for the union, take the number of elements that are in A, add it to the number of elements in B, and you subtract the number of elements that are in the intersection. Because when you added these and these, you added the ones that they have in common twice, so you have to subtract it out once. Okay, we're coming toward the end now. See what we've got. It says they've got the results of a campus blood drive, and said 490 students were willing to donate blood, 340 were willing to serve a free breakfast, and 120 students were willing to do both. How many were willing to donate blood or give or serve breakfast? So here's where the Venn diagram comes in handy. Those are the 490 students. Make that a 9. There we go. Now it says 340 were willing to serve a free breakfast. So maybe make this B for breakfast. And there are 300. Sorry about the writing. I'm not good with a mouse like that. 340 in that. And 120 students. Oops. 340 students. Excuse me. So B has 340 students, the breakfast ones, and 490 all together. So how many students were willing to serve blood or breakfast? So the first thing you ought to do is fill in these blanks. 340 students are in here, which includes this area and this area. 120 students would do both, so you've got 120 just in here, which means how many were in this space right here? Well, 340 is this space plus this space, which means we have 220. They're just here. So we've got 220, 120, we've got 490 all together. So how many belong in this one? Well, these two together make 340. The ones unaccounted for are 150. So there's 150 there. So what have we got? 490 plus 340 minus 120. Cardinal number in the first set, cardinal number in the second set, and subtract the ones in the intersection. A total of 710. Alright, how well did you do on that? Well, if you didn't quite get it, now you've got an idea. Go back a little bit, try it again. You know what the number is, but do you know how to do it? Alright, now these questions are not too hard, but there are a lot of them. Even for an odd numbered group, you would have over 60 some. So I decided every other odd. So what does that mean? Well, the first odd number is a 1. It says alternate odd numbered exercises. So you skip the 3 and do number 5. Skip the 7 and do number 9. Skip 11 and go to 13. All the way up to 131. All right. Well, that's it for this section. Let's give a browsing hand for sets, and we'll see you next time.